Welcome to the deep dive. This is where we really get into the weeds on a topic so you can get up to speed quickly.
Mm.
Today, we're digging into Chapter 1 from an exercise physiology text. It's titled The Performance During the Exercise, Legitimizing the Psychophysiological Approach.
That's right. And our mission really is to unpack this core idea that your brain is actually a major player in how you perform during exercise, maybe more than we typically assume.
Okay, yeah. Because the usual thinking is all about muscles, right? Limits being purely physical.
Exactly. For decades, that was the dominant view. Fatigue was seen as, something happening out there in the muscles, or maybe the heart and lungs couldn't keep up. But this chapter, by Ricardo Ferraz and his colleagues, argues pretty strongly that we need to look beyond just the physical machinery.
So those traditional ideas about, say, running out of fuel or that lactic acid burn,
Yeah.
they're saying that's not the full picture.
Pretty much. I mean, those factors are definitely involved, no doubt. The chapter acknowledges that. But it points to research showing these physiological things alone, they just don't explain all the fatigue we experience. There are other things going on.
Okay.
And that's why there's this shift towards what they call a psychophysiological approach, looking at mind and body together.
Psychophysiological, right. Mind and body. So the chapter breaks down different types of fatigue then. I saw something about peripheral versus central.
Yeah, that's a key distinction they make. Peripheral fatigue is, well, it's closer to that traditional idea. It's defined as basically your muscles losing strength because of processes happening within the muscle tissue itself, away from the nerve telling it to fire.
Gotcha. So that's the stuff scientists were looking at way back, like in the 1920s.
Exactly. The historical view was often about oxygen. The idea was your muscles needed more oxygen than your blood could supply during hard exercise.
Right, leading to that anaerobic state and the buildup of lactic acid, or they called it carboxylic acid back then, apparently.
Mm-hmm. And that acid buildup was thought to directly cause the muscle to essentially fail or fatigue.
And didn't they find that, like, breathing extra oxygen sometimes helped performance, which seemed to fit that theory?
Yes, exactly. That observation, plus the idea that maybe the heart's pumping capacity was the ultimate limit, really cemented that peripheral view for a long time.
Okay, so that's peripheral fatigue. What about central fatigue, then? How's that different?
Central fatigue is about the signals from the brain and spinal cord, the central nervous system, or CNS. It's defined as a decrease in the neural drive to the muscles. So the signal telling the muscle to contract gets weaker or less frequent, leading to a loss of strength.
Ah, so the muscle could potentially contract harder, but the command center isn't sending the full signal.
That's the idea. And what's interesting is the chapter notes that even though people suspected the brain's involvement way back, serious research into central fatigue is actually much more recent, like in the last few decades.
So why look at central fatigue? When does that become the explanation?
Often, it's considered when researchers can't find a clear peripheral cause, like the muscle itself doesn't seem completely exhausted, but the person still experiences significant fatigue. That points towards the CNS dialing things back.
Okay, that makes sense. So the brain steps in. How exactly does the brain fit into this whole performance regulation picture then, according to the chapter?
Well, the CNS is crucial for keeping everything in balance, what scientists call homeostasis, your body's steady state.
Right, like keeping temperature stable, blood sugar, all that.
Exactly. And during exercise, the brain's motor areas are what initiate the movement, recruit the muscle fibers you need. But crucially, the brain is also where cognition happens, where we become aware of sensations. And that includes the sensation we label as fatigue.
Ah, perceived fatigue. That feeling, wow, I'm getting tired.
Precisely. And that feeling isn't just a side effect. The chapter argues it actively influences our behavior.
How so?
Think about pacing yourself during a run or a bike ride. If those sensations of effort become really intense early on, your brain might interpret that as a warning sign.
And tell you to slow down.
Right. Slow down to make sure you can actually finish, or maybe even stop if the feeling gets overwhelming.
So the fact that we don't just go all out until we literally collapse suggests something more than just pure muscle exhaustion is controlling things.
That's a key point they make. Athletes go through different phases, adjust their effort. It implies we anticipate, we regulate based on how hard things feel, based on motivation, not just raw physiological state.
So studying that subjective feeling, the perceived fatigue, is just as important as measuring heart rate or lactate levels.
Absolutely. The authors really stress that. You need to look at the perception alongside the physical changes. They even suggest that because we don't typically see catastrophic failure, like our systems just completely shutting down, it points towards this kind of protective psychophysiological regulation.
Hmm. Protecting us from ourselves, almost. This leads into that idea of a central governor, doesn't it? Like the brain is actively holding us back.
Yes, exactly. They discuss Ulmer's concept from the mid-90s, this idea of a central regulator in the brain. It's not just reacting to fatigue signals, it's anticipating the end of the exercise based on, how long you know you need to go or past experiences.
So it manages how hard you work right from the start to prevent you from hitting a true physiological wall later on.
That's the core idea.
Yeah.
It regulates the demand to ensure you can complete the task without major system disruption. And this anticipatory control, that's what they term teleanticipation.
Teleanticipation. Okay.
Yeah.
Like anticipating over a distance or time. And this isn't just a theory, there's research backing this up.
Oh, yes. The chapter mentions several studies exploring this, and it really underpins what they call the anticipatory feedback model.
All right, let's unpack that. The anticipatory feedback model, what does that involve?
It's essentially a more detailed framework for how this psychophysiological regulation works. It suggests athletes are constantly self-regulating their effort level. And this regulation isn't random. It's based on a mix of things.
Hmm.
Your previous experiences with similar exercise, your knowledge of the task, like the distance or duration,
Okay.
and also the real-time physiological feedback coming from your body. Things like how much muscle glycogen you have left, your core body temperature, heart rate, breathing.
So the brain is like a processor taking all that input past, future expectation, current body state, and calculating the optimal effort level.
Exactly. It processes all this info to predict how things will unfold and regulates your intensity to allow for the best possible performance without causing a major homeostatic disturbance,
Right.
basically finishing safely and strongly.
And how does RPE, the rate of perceived exertion, fit into this model, that feeling of effort?
RPE is central to it. The brain is constantly monitoring all those demands, the physical effort, the mechanics of movement. Our conscious feeling of how hard we're working, the RPE, emerges from all that incoming sensory information.
Right.
And the model suggests the brain continuously compares your current RPE to an expected RPE template. Like,
Mm.
it knows effort should gradually increase towards a maximum near the end of the exercise.
Ah, so if your current RPE climbs faster than the brain expects for that point in the exercise.
Exactly. It might interpret that as, we're going too hard, risk of not finishing.
Mhm.
And then it subtly adjusts your motor output, your neural drive, to bring that RPE back in line with what it deems tolerable or sustainable for the whole duration.
It's like a constant internal negotiation based on feeling. Fascinating. Now, the chapter also mentions something about knowing the duration beforehand. How does that specifically play into this?
Yeah, that's further evidence for this anticipatory control. Research shows that just knowing how long an exercise bout is supposed to last changes how athletes manage their internal resources, their pacing strategy, right from the start.
Even if the duration they're told isn't quite accurate.
Even then, yeah. The expectation itself influences the regulation. It really reinforces this idea that the CNS is playing this proactive central role, likely to preserve that balance, that homeostasis, and keep a bit of an energy reserve, just in case.
So knowing you've got 5K versus a marathon changes the entire internal calculation from step one. Okay, so wrapping this specific part up, how does RPE ultimately relate to performance? Why is it so important?
Well, the chapter frames perceived effort, RPE, as reflecting these underlying sensory changes that are fundamentally about protecting you, protecting your physical integrity.
A safety signal in a way.
You could see it like that, yeah. The feeling of effort, the output, is based on all that sensory input, plus the cognitive processing in the brain. So RPE becomes this really useful, integrated measure. It captures both the feedback from the body and these higher-level brain mechanisms that are doing the regulating.
Which means, for practical purposes,
It means that monitoring RPE, paying attention to that subjective feeling of effort, can be a really effective way to manage and monitor training intensity for basically any kind of exercise, because it taps directly into that self-regulation system.
learning to listen to your brain's assessment of the situation. Okay, I think the chapter also briefly mentioned team sports at the end.
Just a quick note, really. It mentioned that understanding how these psychophysiological factors impact fatigue perception and regulation in the context of team sports is an area of growing interest, building on recent studies. Sort of points to future directions.
Gotcha. So stepping back from the details of chapter one then, what's the big takeaway here? What should listeners really grasp from this deep dive?
I think the fundamental shift is moving beyond seeing exercise limits as purely physical breakdowns. The brain isn't just a passenger, it's the pilot. It's constantly acting as the central regulator, anticipating the finish line, adjusting your effort based on past experience, future expectations, and moment-to-moment feedback from your body.
So fatigue isn't just your muscle screaming, it's a complex signal orchestrated, or at least heavily interpreted and managed, by your brain.
Exactly, which kind of implies we might have more influence over those perceived limits than we sometimes think.
And the practical angle is really valuing that rate of perceived exertion, right? That feeling isn't just noise, it's data. It's your brain's best guess about how to manage the physical challenge safely and effectively.
Precisely. It's a powerful tool if you learn to interpret it.
So, maybe a final thought for people listening. Considering how intricately your brain regulates your effort, always looking ahead, how might understanding that connection change how you approach your own goals, whether that's running a race, hitting a fitness target, or maybe even tackling other demanding tasks in life?
Yeah, how does knowing about this anticipation and the power of perceived effort change your perspective on pushing your own boundaries? Something to think about.